Hey guys, we're going to be looking at the quadratic formula today. Alright, here's some vocabulary that you want to pick up on, brush up on, in particular discriminants. Okay, we'll actually be looking at that in a little bit. Excuse me. So for now, let's go ahead and really try and make this video short. I always say that. Kind of keep my promise at 10 minutes. Let's not go over it. Here we go. The quadratic formula, you can copy this, okay? So you've got your trinomial in standard form. A cannot equal 0. Then the solution or roots are, here's the formula, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay? It's very much a algebra 2 type formula. So anyways, let's go ahead and get into it. Okay? Now, I'm going to go ahead and go hopefully nice and slow and thorough. Now, when you look at a trinomial like that, okay, one thing you'll notice in the formula is that you want to exploit, like we've done in the past, is these coefficients, okay? In this form, you've got a, b, and c. So you must identify them, all right? So the first thing you want to do is identify clearly that a is 1, b is 7, and c is 9. Okay, we've been here before, so it should be comfortable. Next, what you want to do is write the formula. Now notice what this formula does. Okay, you're going to find the zeros. We have found the zeros through different methods in the past. This one, people, works all the time. Okay, so it's an intimidating looking formula, but it is foolproof with real and complex solutions. Anyways, let's go ahead and write the formula. Okay, and yes, write it over and over. Why? Because it'll just set into your head. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So now with the formula, this becomes really a substitution game. Alright, so that means I have negative b plus or minus square root of b squared, 7 squared, minus 4ac. Okay, just good practice. Parentheses for that I'm going to substitute. That's a, and c is 9. All over 2, 2a, and a is 1. Alright, so I've substituted now. I just got to be careful with the math. Alright, plus or minus square root of, here I have 49, minus 4 times 9 is 36, times 1 is 36. All over 2, x equals negative b plus or minus the square root of, what is this here, 13 over 2. I next have x equals negative 7 plus or minus, well, that's it. I'm pretty much done. What I'm referring to is you could divide this by half and this, but that just gets it a little more complex looking. So this is sufficient. Okay? So let's move on. Alright. Now, this one says find the zeros of this function. Okay? I'm not going to go through the entire thing here because it's identical to the other one, but I will start it. Okay? So the first thing that I want to do is identify what a is clearly. Okay, see, like for example here b, some people might put 0, different things like that. They might just put a 1, but it is a negative 1, and c equals 5. So this, right, these kinds of situations is your focus. Okay, you really want to be an expert at identifying the coefficients because now you simply plug into the formula. Okay, it says quadratic formula. So I'll write it out here and let you guys try it out on your own, but it's the same thing. You're going to substitute into this and then simplify the math, okay? B squared minus 4ac all over 2a. Done, all right? So one tip that I'm going to recommend is that you maybe write the skeleton of this formula so that you can just substitute in the corresponding values. And I think this will actually help avoid little pitfalls because now, right, these blanks just get filled in accordingly. Alright, so I'll leave that for you guys to kind of work out. We can explore that tomorrow in class. Now the last thing we're going to look at is the discriminant. Alright, you see how it says b squared minus 4ac, guys? Well, check this out. It's the same expression underneath the radical in the quadratic formula, the b squared minus 4ac. So you can actually use that alone for something unique. Okay, not for the solution, but something close to it, and here it is. It's when that expression, okay, is greater than 0 or basically positive, you're going to have two distinct real solutions, okay, two of them. If this expression underneath, okay, is equal to 0, then you've got one distinct real solution. And if it's negative, right, so this one's 0 equals 0, if you have this expression be some kind of negative, then you have two distinct complex solutions. So let's look at an example that involves this discriminant. Find the number and type of solutions for x squared minus 9x equals, okay? So the first thing you're going to have to do with this is write it in standard form, because like with the quadratic formula, the discriminants, no doubt the same thing, right? It requires the knowledge of A, B, and C. So I'm going to avoid problems by writing this in standard form. So if I just add 8 to both sides, I now have x squared minus 9x plus 8 equals 0. All right. Now the use of the discriminant is what? B squared minus 4ac. Okay. So this is what I'm going to be using in a bit. Anyhow, let's go and identify A clearly, B, and C. Right? A is obviously 1, B is negative 9, be careful, and C is 8. Right? Notice how you must have the x squared, then the x, then the 8 for the constant. Anyways, now I'm going to plug in here, and I have, right, I'll even do the skeleton for this discriminant. Minus 4 times something. I need a b in there, negative 9. I need an a in here, which is a 1, and a c, which is an 8. So now I'm going to clean up the math. Okay, if you're not sure, hit the calculator, but this is 81 minus 32. If I'm not mistaken, this is 49. And because 49, people, is greater than 0, I can now use this information. I did go fast, but you can pause it and record this. And because my discriminant is positive, I have two distinct real solutions. Alright, so find the number and type of solution. So it's got, okay, two solutions. Whoops. And what else did it say? So the number of solutions is 2 and the type of solutions. Okay, what that's referring to is that they're real solutions versus complex or imaginary, right? This is where you think of I. So we can say 2 solutions, and in parentheses we'll put real, and I'll put equals this symbol that some of you guys have seen that you're not too comfortable with. Anyways, I'm going to stop it right here. Thank you guys for your time. I'll see you tomorrow.